Good day, everyone. I'm Jimmy Kapadia. I'm the manager of Electrified Systems Analytics at Ford Motor Company, and I'm here to talk about connected vehicle data analytics and what we do at Ford, specifically to electrified powertrains. So in 2017, Ford announced that every new Ford vehicle in the US would be equipped with connectivity. 4 years, 5 years later, we are at the cusp of getting all this data from all our vehicles that are equipped with embedded modems. So when we generally talk about connectivity, we talk about customer-facing features, but there is another side to it, which is where my team really comes in, and that's the benefits to the OEMs. So I'm going to talk a little bit about how we internally use connected vehicle data. So from a systems V approach, I've highlighted really two areas where we use connected vehicle data. These are just examples. There are other areas along the systems V where we use connected vehicle data. But at the very top left of the V, we have system sizing and design requirements for the various systems, subsystems, and components. And then on the very right side of the V, we have warranty and maintenance, and really using connected vehicle data to understand and even anticipate some of the field quality issues experienced by our customers. So I'm going to take you through each one of these in a little more detail against the backdrop of electrified powertrains. So system sizing. Really, the insights from connected vehicle data can help optimize system, subsystem, and component level designs. So an example here is for the upcoming Mach-E GT. The high voltage fuse team came to us saying, how do we size the fuse? We did not, of course, this was many years ago, we did not, of course, have electrified vehicle or Mach-E GT data. So we used surrogate data. So we looked at our conventional Mustang Mach-Es to see what percent of the time did those customers go to wide open pedal. And of course, going to wide open pedal means that there is a large amount of current that needs to flow through the fuse, and the fuse needs to be sized accordingly. And as you can see from this distribution, it was a relatively small percent of the time, which led to the team to size the fuse appropriately and thereby save a few dollars on the cost of the fuse. And if just for a small little component like the fuse, if you can save a few pennies or a few dollars, just imagine what you can do for designing of some of the more expensive components like the battery and the motor. So moving on to the warranty and maintenance side of the systems V, getting data directly from the vehicle can greatly speed up issue resolution. So if you look at the traditional issue resolution timeline, you have an issue that's first present in the vehicle. That issue may or may not be indicated to the customer. And over here by issue, I really, if you want to kind of put in DTC that is set in the vehicle. And that DTC may or may not throw a light on the dashboard. But then once the customer is notified of the issue, then there is a certain amount of time lag for the customer to schedule an appointment and bring the vehicle into the dealer. The dealer then diagnoses and fixes the vehicle, files a warranty claim, and that is really the first time that the engineering teams get to know about the issue. And that is when our resolution clock starts. With connected vehicle data, of course, the very first presence of the issue in the vehicle, we get an indication via connected vehicle data, and within days or even within hours, the resolution clock starts. So that is a significant time save. In our experience, it's typically between 2 to 6 weeks. In some cases, it's even longer. And 2 to 6 weeks is a long amount of time considering the number of vehicles with the issue you would produce in the 2 to 6 weeks. And while that is impressive, We think that the real benefit of connected vehicle data is to do prognostics and identify signal trends that are trending towards the fault threshold, as opposed to waiting for the fault to set. And for the marquee, we do exactly that. We monitor a number of signals from some of the electrified components in the vehicle, and run those signals through a machine learning algorithm that puts out anomaly scores. And the anomaly detection for example, of the high voltage battery can provide internal warnings to the engineering team, which can then go and investigate. Really, the trick over here, or the smarts over here, is to set that threshold. You don't want the threshold to be too sensitive, so every little blip is sent to the engineering team to discover. But at the same time, you don't want it too relaxed, so you send the threshold, you send the trigger right before the DTC or the fault is being set. So circling back for the systems V, for system sizing, you over-design, you spend money up front with the wrong requirements. You under-design, you spend money later in warranty cost. So really, the bang for the buck here is to right-size the components based on customer usage to optimize the design. And then on the warranty and maintenance side, quicker identification of the DTCs, faster diagnostics, and this is an area that I didn't cover, but along with the DTCs and the issue, you also get a lot of supporting information like temperature or the conditions that the vehicle was operating in. And all that can go into the engineering team for a quicker resolution. And then, as I covered, the prognostic capability, where we detect and recognize issues before the fault is set. So, summing it all up, at Ford, we believe that our vehicles are quite literally talking to us, and we should listen to them carefully, and that's exactly what we are trying to do currently. Thank you for your time.